Hi all, welcome back. So today we are going to discuss about the special matrix called the Pauli matrix, and its useful is its application is effective and is useful in various domain. So in this lecture and very small clip video, we have to try to understand this special matrix. All right. So let us start. So polymetrics, quantum strength is highly useful in engineering fields, mathematics and physics. So let us like what's the main application of this matrix, this classical rotation basically generally be used in our continuous variables. All right, we use in continuous variables generally classical rotation, and in case of quantum system we focus on the discrete states. All right, and the classical rotation generally state the continuous variables. Okay, so since in quantum system discrete states to be involved, so need operators instead of scalars. So we require the operators instead of the scalars. Okay, so basically Pauli matrix is a equivalent to a smallest non-trivial operators. Okay, so two state system called the qubit, 0 1 comma 0 1 and 0, this is like row, sorry, column matrix, and 1, this is 0 1, we can write like that. Okay, and so this is psi a assertion 0 and plus b and this one. Okay, you can write down here. So basically here what is the magnitude here, a square plus magnitude of b square is equal to 1. It's like a circle. So how we can interpret here, basically interpretation like spin up and spin down. Okay, so rotation we have to involve. So rotation it can be spin up and spin down. So Pauli matrix involved like sigma x is equal to 0 1 comma 0 1 1 0. Okay, so this is not like identity matrix. Identity matrix is like that. This like principal diagonal should be 1. Sigma y is equal to 0 minus I and 0. Alright. Sigma z is equal to 1 0 0 minus 1. Okay. This is called like um, can we say skew matrix sigma z? Let us see that. So what does actually here? Sigma x does the flipping. Sigma y does the phase plus flipping. Phase also get changed. And sigma z is compared with the does the measurement basically. So apply sigma x on 0 step by step operator action. Okay, this is like operator looks so we can see how we can do sigma x 1 0 equal to 0 1 and apply sigma x on 0. This we did actually 0 1. So this is called the spin flipping. Where is a 1, put the 0 and 0. Okay, so this gets flipping. So a spin flipping interpretation. Okay, and operator action like sigma is on 0, so this we already discussed. And if you put sigma z on 0, so sigma z 1 0 is equal to 1 0. So there is no, this is same actually, right? So it means this is called the eigenstate. Okay, so here this is called the measurement unchanged, there no change at all. Okay, but if you apply sigma x, it will get flipped. So key properties, sigma pseudo equal to pseudo, sorry, conjugate we can say here, equal to itself is a give the same value sigma. So key property has been seen. Square properties, sigma I square I equal to I, identity matrix. Okay, and commutation, sigma x sigma y equal to 2i sigma z. Okay, so order matters basically. This is called the core quantum effect. Order matters. Okay, so this is called the core quantum effect. So this is actually basically involved in a Lie algebra structure. So sigma I sigma z j is equal to 2i epsilon I j k sigma k. Okay, so this forms in the Lie algebra and 2 by 2 matrix. Okay, so this is basically equivalent to rotation algebra where rotation involved. Okay, so this is called the 3D domain, basically 3-dimensional, only rotation to be involved, equivalent to rotation algebra. So Lie algebra structure is equal to sigma ai sigma j is equal to 2i epsilon I j k sigma k. So we have forms SI Lie algebra, so equivalent to rotation algebra basically. This already discussed and important for the robotics control. So this is very helpful in a, to be used in a robotics domain. So below space visualization you can see here x by z. So here you can see state basically point on the sphere. Okay, so where is a point on the sphere, we can say the this called the state. So rotation operator is a e power minus I theta sigma n by 2, n is a script actually. So so this generates the rotation in quantum space. Okay, we will discuss what is actually quantum space. And here actually we are discussing and understanding the properties of Pauli matrix. So here Rn is equal to e power minus I theta sigma n by 2 generates rotation in quantum space equivalent to rotation matrix. This is actually called the rotation matrix and quaternions. We'll discuss actually what is a quaternions actually. So rotation operator e power minus I theta sigma n by 2 generate rotation quantum space equivalent to rotation matrix quaternions, and this is helpful in bridging to robotics kinematics. When we studied the robotics, so rotation to be involved, the rotation nothing to be happened in the robotics. So this is frequently use this algebra basically. Okay, so let us to understand the what's the spin up and spin down. So here you can see, let us psi put 1 by under root 2, 1 by under root 2. So what is the mean actually? 1 by under root 2, 1 by under root 2. Expectation value here coming is 0. Okay. So here basically whenever is coming this value coming 0, so what does that mean? Equal probability of the up and down. So basically there is no spin up and down basically. Okay, so general representation A is equal to A dot I plus AX sigma x plus AY sigma y and AZ sigma z. Okay, general representation is A not AI plus sigma AX sigma x plus AY sigma y plus AZ sigma z. So any 2 by 2 Hermitian matrix. Okay, so Hermitian matrix is basically uh, its conjugate still get the same matrix basically. So this is called the Hermitian matrix. So this complete the basis and used in the quantum Hamiltonians. Okay. So application basically in the spin systems and magnetic fields in physics. Okay. So physics generally be used in this Pauli matrix and properties used in physics spin system and magnetic fields. Quantum computing, qubits and gates we can use in quantum computing. Okay, and engineering domain where it to be used in a rotation algebra, control system, and robotics domain, robotics field basically. Okay, so deep engineering is said actually Pauli matrix basically generator of the rotation. So this is a very important generator of the rotation, Pauli matrix. So deep engineering inside Pauli matrix is called generator of rotation, similar to skew symmetric matrix and angular velocity operators. Angular velocity also is like a looks like a skew matrix. So Pauli matrix we understood generators of rotation, similar to skew symmetric matrix. Angular velocity operators connection is R dot is equal to omega cross R. Okay. So quantum robotics connection. Some Pauli matrix describe quantum spin and non-commutativity and terms of fundamental physics basically. So this form the Lie algebra. So direct link to rotation, control system, robotics math. So Pauli matrix to be involved in this, highly useful. Okay. So actually basically here we just understand the Pauli matrix application and just basic fundamentals of it actually. So in the coming lecture we will try to go more deep dive into in this so that we get more clarity. So let us just focus on the application point of view. So this to be used in a spin system, magnetic fields in the physics perspective, in quantum computing, qubits, gates to be used here, and engineering domain it use rotation algebra, control system, of course robotics here rotation to be involved. So this to be used here. Okay. So that's all in this actually. We will come up with our new lecture and try to dive more concept in this for the same. Okay.